Hi there, welcome to my channel Mandu to Fundu. In this video, I'm going to discuss about the solution for finding the number of islands in the grid problem. Let's look at the problem description. We are given an m by n 2D binary grid, and in that the value 1s are representing the land and 0s are representing the water. We have to return the number of islands. So an island is surrounded by the water and formed by connecting the adjacent land horizontally and vertically, and we may also assume the grid is all surrounded by the water. Okay, let's take a look at an example 1. So in this, all the ones are connected horizontally and vertically together. There is no zeros in between, so the total number of islands in this is 1. In the case of example 2, we have an island, the ones which are connected horizontally and vertically is, this is number 1 and this is number 2. There is no ones horizontally or vertically around it, and for this is 1. So totally 3 islands in this grid. So the m is the grid length, and this is the number of columns, and the value of m and n is ranging from 1 to 300. The grid's value can be either 0 or 1. Let's look at the approach to solve this problem. So we have this input grid, 4 by 5 grid. So the expected output is 3 because it has 3 islands. So basically we can look at this problem as a graph problem. So on each entry in this grid is a vertex in a graph. Each vertex is connected to the neighbors horizontally or vertically, not diagonally. So for this node's neighbors is this and this. So in order to count the number of islands, we have to count the number of graph traversal that needs to be done on this graph so that all the nodes are visited in the grid. That's the basic idea for solving this problem. So we have to do graph traversal as many times as needed until all the nodes are visited. Let's look at the flowchart. Input for this procedure is a grid which contains ones and zeros, 1 indicating the land area and 0 indicates the water area. So first we initialize the rows, columns and the components variables. Rows indicates the number of rows in this grid, column number of columns in this grid, and the components will, at the end of this procedure, it will give us the number of islands. So initially we set that to 0. Then we create a 2D array, integer array of same size of the input grid, so that we track whether that particular vertex is visited or not. Initially, starting from the index 0, 0, we go 1 by 1 in the grid and check whether that node is not visited and also that node is a land. In that case, we increment the components count and start the breadth first traversal starting from the vertex I, j. So this will, once that traversal returns back, we increment the j plus 1 and we check whether that particular entry in the grid is visited or not until we traverse all the elements in the grid through these nested for loops. Through these loop, we try to visit all the nodes. At the end of this loops, finally we get the number of components. So each time new breadth first traversal is initiated, the component count will be incremented. So fine, at the end of these two loops, we get the components count. Let's look at the flowchart for the breadth first traversal. So the input for this procedure is grid and visited 2D array and vertex, starting vertex. First we initialize the queue with the starting vertex and mark that vertex as visited. Then in the outer loop we always check for elements in the queue. If the queue is empty, we are done with the traversal. Otherwise we dequeue the first element and then get the neighbors of that element and then process the neighbors list. So we keep checking whether the neighbor list is empty. If so, we go for the checking the queue. Otherwise we continue to process the neighbors in that list. So first we dequeue the element from the neighbors list and check whether that neighbor is not visited. If so, we mark that node as visited and add it to the queue so that neighbors will be pulled in the next iteration. So if the dequeued neighbor is already visited, we simply go to the next neighbor and check the same. So we until we all the neighbors are processed for that particular node. Once that is done, then we go to the outer loop and check again for the queue is empty. The queue basically contains the next level elements. So once the queue is empty, then we come out and finish the traversal. Let's move on to coding. First I define the vertex structure, which combines the row index and column index of the cell in the input grid. Then I define a constants for not visited and visited states, and then define a constant for the land and water values. Inside the num_islands function, I initialize the rows and columns variable, and then I create a visited 2D array to keep track of the status, whether the vertex is visited or not. Next, in this nested for loop, I initiate the breadth first search whenever not visited vertex is encountered, and that vertex is also land. Okay, so I forgot to initialize the components counter, so now I am doing it. And whenever I initiate the breadth first search, I increment that counter so that at the end of this nested for loop, we get the total number of components present in this grid. Now I am writing the function for doing breadth first search, which takes the grid and the visited array and the starting vertex as an input. First we initialize the queue with the starting vertex as the only element in it. Then I mark that current node, the current vertex as visited. Then the outer for loop starts, which checks for elements in the queue. If there are elements, it will dequeue that, and it tries to find all the neighbors of that node. Now I get the neighbors of the current node. Then I iterate over that neighbors list and check whether that neighbor is already visited. If it is not visited, then I mark that as visited and add that node to the queue. This nested loop runs until there is elements in the queue. So once all the elements are processed, it returns back to the num_lines function. Next, I'm writing the get neighbors function, which takes the grid and then the vertex. Then it will return the slice of vertex. First I initialize the neighbors list, and then I define a distance array. Basically this distance is the distance between the current node and its neighbor. So either it is 0, 1, 1, 0, 0, -1. Then I iterate over this loop and add these distance with the current vertex, and then check whether that is in range within that rows and columns. In that case, I will declare that as a valid neighbor, provided, and also I check whether it is a land. So after the boundary conditions are checked, I also check whether the grid element is a land. If so, I add that to the neighbors list for that current node. And finally I return that neighbors list back to the breadth function. Next I'm going to run the test cases. It passed. Next I'm going to submit this program. Cool, it's accepted. Next I'm going to do the code walkthrough with sample input. So we have this input grid, and for this input the number of islands is 3. So let's see how we compute this output. So the num islands function first initialize the number of rows and columns and create the visited array to keep track of which vertices are visited in that grid, and we initialize the component to 0. To begin with, we started our traversal at index 0, 0. So this is the starting vertex of the traversal. So at the end of so once we enter, we check this particular vertex is not visited yet, and that is a land, meaning 1. So both the conditions met, so we increment the components count and then initiate the breadth first search starting with the vertex 0, 0. So at the beginning of the traversal the components is 0, at the end of the traversal the component is 1 in this after the traversal. So when the traversal first traversal is done, the traversal ends at here, and then because of this these two loops we keep checking whether this node is visited already. Yes, it is as part of the previous traversal, and this is 0, so we are interested only in land. So all these things three vertices are skipped, and then these two vertices are already visited as part of this traversal, so the next 3 zeros are also ignored, and the first 2 is also 0, so this is also ignored. Then we ended up this vertex which is a land and not yet visited. This condition is met, so we increment the components count and initiate the breadth first traversal. This node do not have any neighboring vertex which is 1 and also horizontally and diagonally adjacent, so all are zeros. So that means this is the only node in that island. So we come out of this breadth first search, and then we continue checking whether this node is visited. This is 0, so we ignore that. This is 0, we ignore that. These 3 nodes will be ignored because of zeros. Then finally we ended up this node which is a land and not yet visited. So the next breadth first traversal will be starting from this node. So at the end of the traversal the components count will be 2 for the traversal started in this node, and then the third traversal starts from this node. So after that these two nodes will be forming an island. So finally we get number 3. The components total number of islands is 3. And let's quickly take a look at the code walkthrough for the breadth first search. So initially, so let's go to the breadth first search code. So whenever the breadth first search function is called with the starting vertex, first thing what we do is we initialize the queue with that vertex as the only element in it, and we mark that element is visited. So that means we put 0, 0 in the queue and we mark that node is visited, and then the queue is checked for elements. If there is an element, we enter the loop and dequeue the first element, and then we get the neighbors of that, the current element. In this case the current element is 0. Okay, so who are all the neighbors? Horizontally horizontally the cell which is having 1, this is a neighbor. Then vertically the node which is 1 and also not visited yet. So the neighbors of this node is 1, 0, 0, 1. So that's what we get the neighbors for this node. Then the inner loop will iterate over the neighbors list. So in this case there are 2 entries. So first we get 0, 1. We check whether that is not visited. Yes, it is not visited. And so we mark that as visited and then add it to the queue. So the queue has now 0, 1. The second neighbor is 1, 0. We check whether 1, 0 is not visited yet. And then we mark that as a visited node and we add that to queue. So now we have 0, 1, 1, 0 in queue. And so the inner loop completes now. Next we come out of this inner loop and then again we check whether the queue is not empty. So the queue has 2 elements in it. So we dequeue the first element and then we get the neighbors of this element, which is 1, 1, and we add it to the neighbors list. And also the 0, 0 is also a neighbor for this node 1, 0. So 0, 0, 1, 1. These two are neighbors of 0, 1. So now we go to the inner loop and take one neighbor at a time, and first neighbor is 0, 0, which is already visited. So we go to the next iteration and then the next neighbor is 1, 1, so which is not visited yet. So we mark that as visited and add it to the queue. So once this is done, then again it will go back and check the neighbors of this 1, 0. 1, 0's neighbor is 1, 1, which is already marked as visited. So nothing will be added to the queue. Next 1, 1, it has 2 neighbors, but both of them were already visited. So nothing gets added to the queue. The queue will be empty. We come out of that loop. So in this traversal, we traversed 4 nodes, 4 vertices. Next I'm going to do the time and space complexity analysis for this solution. We have this input grid. So the number of islands for this grid is 3. And in order to find the number of components, we have to traverse all the vertices in the grid. So which is the 4 by 5 to 20 nodes we have to traverse to conclude to find the total number of islands in that grid. So the complexity is order of n, where n is the total number of elements. And the space complexity is order of n, because we need to allocate space for whether the node is visited already or not. So for this we have to allocate space to accommodate all the input vertices. So the space complexity is order of n. Thanks for watching this video. Have a great day.